Okay, here we go, guys. So here we're going to do a complete breakthrough of the Goldsmiths College numerical maths paper, and this is the sample paper for the 2017 examinations. Okay, without further ado, let's get going then, yeah? So in this paper, I'm only going to do part A, okay, and there's quite a lot of questions. I'll see how far I get up to. So multiple choice. All right. So question 1, what is the decimal value of this binary sequence? So here we go. 10, 10, 10, 10, all to the base 2. And the key idea is to rewrite this figure into base 10. The cool thing is, if you're moving from a base 2 to base 10, we just start from the very first unit digit, where we can write as 2 to the power 0, and then follow up with every sequence in ascending powers of 2. So it'll be 2 to the power 1, 2 to the power 2, and so on. If you got 0, well, you're going to have to multiply these terms by 1 or 0. If you got 0, we can ignore it. So we have 2 to the power 1 here, 2 to the power 3, 5, and 7. So just sum them up. So in your calculator, write 2 to the power 1 plus 2 to the power 3 plus 2 to the power 5 and 2 to the power 7. And this will give you your answer back into ordinary decimal numbers, the numbers we use in real life. And this should give us 170. Sweet. Okay, part B. So what is the fractional representation of the following recurring decimal? So here there's actually a really cool trick how to do this. All you need to do really is just look at these values here and then just take the first 3 decimal recurring numbers, because you can see that's recurring in 312s, 312s. So pull it to the side here and write 312 as a fraction over the number of digits in terms of 9. So it'd be 3 digits, so 3 9s. And that's it, this is done. And because we got a whole number 2, well, just put it in front, so it'll be 2 plus all of this. And that's it, that's literally how you rewrite a recurring decimal as a fraction. So put that in the calculator, what you get? I'm typing it down, and I got 720 over 333. So it's the second response. Cool. Part C, so what is the smallest positive number that is congruent to 899 times 286 in modulo 128? Alright, so a few things to notice here, yeah? So let's look at this word congruent. In triangles, this is more or less saying when you have two triangles that are congruent, it means they are the same. So this is the same. So what this means here, that you need to find a number that is the same as this in mod 128. And it's also the smallest positive. So this word means identical or same. So it can also mean identical. So we need to find an identical figure in mod 128. Alright, so first thing you want to do is smash this in your calculator, 899 times 286. And you should get 286. 200, so let me write that, so 257,114, and this is in mod 128. Alright, so be careful. The first answer is not going to be the smallest, is not going to be the answer, because they want the smallest positive. So I'm going to quickly just cross this out now. Okay, so what you're going to do here is that you're going to have to keep on reducing this. So a good trick is to divide it, because remember the value here can also be known as the remainder. So divide against 128. So in your calculator, write 257,114 over 128, and keep it as a mixed fraction. So use the Shift SD button if you're using a calculator, and let's see what we get. So answer over 128, Shift SD. So I got 2008, and then I got a fraction which says 45 over 64. You want to write it over 128, so double that 64 to get 128, double 45 to get 90. And behold it, so this top figure here, guys, is known as the remainder, okay? So this is the remainder, and this figure here is the quotient. When you're writing a mod, you just need the remainder mod whatever number, in this case 128. So the remainder is clearly 90. So this is, guys, the smallest positive number that is congruent, and unfortunately these numbers they don't qualify. So the answer is going to be none of the above. All right, fantastic. Let's move on. So triangle has sides x equals 13, y equals 8, and angle x equals 52. Find the size of angle which has no possible triangle. Okie dokie. So what do we do here? So just draw a triangle XYZ. Just a regular triangle, label the side X, Y, and Z. Now, all we want to do is just fill out the missing piece of information. So what we could do, let me just make it a bit lower, that we got angle x. So this corners can represent angles here, yeah? So angle x, and we got length small x. So the length opposite the angle can be small x. So this would be length 13. Y equals 8 would be the length opposite the capital Y, which would be 8. And angle x is 52. So this means this part here is 52 degrees. All right, that's easy. And we want to find the size of angle y. So let's call this one y. Now, how do we do this? Well, there's two rules. For every single triangle, we're going to either use the sine or cosine rules. Okay? And the key idea is that if you're going to use a cosine rule, you must have 3 lengths and 1 angle that you're working with. Okay, unfortunately we have 2 sides of 2 angles, so automatically we're going to have to use the sine rule by default. So this is always check the cosine rule if it works. If it doesn't, then the sine rule straight off the bat. So we could say the sine rule states that we're going to have, for example, sine x over x equals sine y over y. So it's kind of artistic in that sense. So here we're going to have sine y over y, which is 8. Let's write it here. So sine y over 8 must equal to sine 52 over 13, because they're all opposite sides. And now all we have to do is make sine y the subject. So by multiplying 8 across, we're going to have sine y equals 8 times sine 52 over 13. Now put this in your calculator, and then once you smash it in the calculator, you're going to have to sine inverse this answer, and it should give you, I believe, 29 degrees. Easy stuff, guys. Easy stuff. Let's go. Oh my god, this is super easy. So convert 30 degrees to radians. So this is just an idea of changing degrees to radians. And all you have to really know is that we always need a start point. So we always use 180 degrees as our base, because this is equal to pi radians. Okay? So I'm going to use the ratio symbol because that's better used to represent. So every 180 degrees is pi radians. So we could say that for every 1 degree, if you divide it by 180, it's the same as pi over 180 radians. That means to find 30 degrees, we just have to multiply this answer by 30. And if you do that, you're going to get exactly pi over 6. Or in your calculator, it should say 1/6 pi, which is the same thing, guys, yeah? That means clearly it's the 4th solution. Next one, converting these two coordinates to polar coordinates. So one thing to note, these two coordinates here are in x and y's, yeah? And they're also known as, the official term is called Cartesian coordinates. Okay, so Cartesian coordinates is your typical x and y graph in this form, x and y. Now, in order to work out polar, you need to check how this works. So in typical Cartesian, if you're going to plot this in x and y, because it's root 2 and root 2, we can just imagine root 2 being here and root 2 being here. So let's say this is root 2, root 2. And in order to work a polar, we need to start from the center and then draw a line, a straight line to this coordinate. And then we need to see how we travel there using Pythagoras. So we traveled root 2 across and root 2 upwards. And then we measure the angle from 0 degrees up to here. We call this theta. So if we pull this across here, we're going to have to basically work out the angle from the baseline up into the diagonal and call this theta. And we've got a length of root 2 and root 2. So two things, we need to find the angle and we also need to find the radius, because polar coordinates are always written in r and theta, where r is the radius and theta is the angle in radians. Alright guys, so to do this we need to use, of course, SOHCAHTOA, see which one is needed. Because we were working with these angles, with these two lengths, we can see that the length opposite angle is known as the opposite, and this one's always the adjacent. So we need O and A, and O and A thankfully is in TOA. So our equation of value is going to be tan theta equals O over A, so root 2 over root 2. And now we just tan inverse this, so tan inverse of this value should give us pi over 4. And guess what, guys? Pi over 4 is not in these solutions. So unfortunately the answer automatically is none of the above. Okay, part G. So what does it say? So it states that 2 log base 2 to 3 is equal to one of these terms. Well, let's look at our log rules here. So when you got something in this format, let's call it n log, say k. Well, I'm not concerned about the base here. The general rule is that when you have a term in front of the log, it's the same as writing the log itself, but k to the power of that term n. So what do we have? So we've got 2 log this term. So 2 log, let's put the base 2 for the sake of it, 3. So because we've got 2 in front of the log, we're going to rewrite the log in its full form, but now the 2 is going to be represented as a power. So 3 squared. And we know 3 squared is simply log 2, 9. Now having a look at this option, see if this option is available. Well, clearly it's not this one. 2 log 2, 5. Well, if you work this out, put 2 in front, becomes 2 squared, 5 squared, so it becomes 25. So clearly not. This becomes 64, and well, unfortunately, this is also wrong too. So actually, the only possible solution is the one I'm going to add right now, which is log 2, 9. So guys, in your solution sheet, all of these answers are incorrect, so wrong, unfortunately. Okay, so the answer is log 2, 9. Another way to do this is literally just smash this figure in the calculator, keep the answer memorized, and then check out all these values and see if you get the same answer. You definitely won't, because I've already tried it, and the only way to do this is to square the 3. Okay, let's move on. So let's look at part H. So we have the graph of fx, which is a to the power x. So what is a to the power x? Well, this is just a power function. So a power function always starts from just above the x-axis and it just shoots up like this. This is called the a to the power x graph, and it always intercepts the y-axis at the value of 1. So we just have to memorize these terms, yeah? So looking at this carefully, the graph of fx has a y-intercept of 1, yes. So this is true. An x-intercept of 1, nope, it never touches the x, false. Passes through the point 0a. So where is 0a? Does it pass through the point 0a? So when x equals 0, what do we get? You get a to the power 0, which is 1. Nope, it passes through the point 0, 1, which is over here. Passes through point a0. Let's have a look. When you have a to the power a, that definitely does not equal 0, guys. Yep, and that's it, unless a was 0. But then even so, a to the power 0, 0 to the power a is still 0. Nope, so the answer is definitely false. So this is false and this is also false. Okay, here we go. So now we're in question I. So given that we have this equation here, we need to, of course, in this case, all the answers in dy of dx. So here they're asking us to differentiate this equation. So differentiation is part of calculus, and differentiation, thankfully, is very straightforward and easy. So let's give an example. Suppose we let y equal, just to explain the process, x to the power n, where n is just a number, yeah? In order to differentiate, we need to drop the power of n on the ground, so we have nx, and then we subtract this power by 1. So n take away 1 is n minus 1. That's literally the process. This rule is known as the power rule. So thank God it's very straightforward. Now let's go back to the original equation. So we're given y equals 2x cubed plus x squared minus 2x to negative 2. So let's go ahead and differentiate this, yeah? So differentiating 2x cubed, we drop the 3 down, so we've got 3 times 2, which is 6x. Subtract the power of 3 from 1, so 3 take away 1 is 2, so 6x squared. So this means the first one is obviously false. Next one, plus x squared. So differentiate x squared, drop the 2 in the ground, so we have 2x. 2 take away 1 is 1, so x power 1. We don't need to write that, thankfully, so that's fine. Next one, 2 and minus 2x to negative 2. So drop the negative 2 in the ground, so it will be minus 2 times minus 2 is plus 4x. And then subtracting minus 2 from 1, so minus 2 minus 1 is minus 3. Be careful, it's not minus 1, because minus 1 take away 1 is not minus 1, it's minus 3, guys. Okay? And now we just carefully look. So which one's right? So these are all okay. So this is negative 1, so that's false. This is false. That means the only answer is part 3. Okay. Now, all right, so this is the kind of question I really enjoy. So SUVA equations. So you may use the following kinematic equations, i.e. the SUVA equations. So you're given a bunch of SUVA equations. So let me just write the SUVA equations here. So we've got SUVAT. So where you go, S is the distance, U is the initial velocity, V is the final velocity. These are velocity pairs. A acceleration, T time. Now what do we have? So we've got a particle moves with constant acceleration, so acceleration is fixed. Its initial velocity is 0, so the initial velocity is 0 meters per second squared. No, per second, sorry, 0 meters per second. So this tells us that u equals 0. And its acceleration is 2 meters per second squared, so a is 2. Find the time taken, so we don't know what the time is, question mark, if the particle travels a distance of 8 meters, so the distance is 8. Now, this is so easy and cool. So all you really have to do here is pick an equation from the list that has all of these four terms, that has S, U, A, and T. To make your life easy, find a term that cross the equation that has a V, because we don't want final velocity. So let's have a look. This hasn't got a V. This one has a V here, so cross. This has a V squared, cross. This has a V, cross. So our only possible equation, of course, is the first. So we're going to have S equals UT plus half AT squared. Now plugging in all your values over here. So S is 8, U is 0, so 0 times T is of course 0, plus half, A is 2, and T, well, we're trying to find that, so T squared. Now tidying this up, we're going to have zeros, that's gone, so we've got half times 2 is just 1, 1 times T squared is T squared, and lastly, square rooting to find T will give us root 8 seconds. So the time was root 8 seconds. So the answer is this. Nice. Okay. K. Calculate the following limit. So this is the limit as x approaches 2 plus. So just know 2 plus means a number just above 2. So it's kind of like 2.00000001 as an example. Now all you have to do is pretty much replace this 1 over x minus 2 with the value of 2 plus, which is 2.0001. So in your calculator, just literally write this with loads of zeros and a minus 2. And then when you do that, you'll notice that the answer will be very big. It'll be like ones with many zeros. In other words, if you get a massive answer, then you're more or less heading to positive infinity, to a huge fat number. So the only possible answer is these two. These two are definitely wrong because they're negative, and half is wrong because it's a tiny number. We're not going towards 0 or half. We're going towards infinity. Okay, here we go. So question L. So given y equals e to the power 5x and solutions are so spaced out, you're given various solutions with dy over dx, it seems. So the question is to differentiate this. How do we differentiate an exponential equation? Easy. So let's imagine a typical exponential. So let y equal a general one. Let's say e to the power nx, yeah? Where n is a number. To differentiate this, all you have to do is literally drop the power down. So differentiate nx will just give us, well, n. So drop it down, you can get ne, and then you just copy the rest, nx. That's it. So it varies, you know what the equation is. Because it's just 5x, differentiating 5x gives you 5. If it was something crazy like, I don't know, e to the 5x squared or something, you go differentiate 5x squared using the power rule. So drop the 2, you get 10x. And then you stick that in front of the e, so it'll be 10x, and then you copy the rest, e5x squared. So the whole point is you copy the exponential expression, but every time you differentiate, you just drop it to the ground. So let's have a look at this one. So we got y equals e to the 5x. Differentiate this by dropping 5x. So differentiate 5x give you 5, drop it to the ground. So dy dx equals 5e, and then copy the rest, 5x. And that's our answer. So 5e, 5x. So now, it's a birthday. Happy birthday, man. Now, C. Okay, great. Oh, God. Oh, go away. Okay, yeah, because it's 12 on my time. It's a certain hour, so that's why it does this. Okay, let's move on. So question M. So rewrite the following vector in terms of standard unit vectors. So we've got 1, minus 2, 2. So just to let you know, this is known as a column vector. Standard unit vectors are in terms of I, J, and K's. So a bit like X, Y, Z, but vectors we use I, J, K. And yeah, so we just need to know what this is. So 1 represents positive I or positive 1I. Or positive I, This second one is minus 2j, and the third one is positive 2k. Now we just look at the expressions. So, oh yeah, sometimes you can write an arrow instead of a line. So would it be the first one, positive I minus 2j? Yep. Yeah, so okay, I guess we're done. This is the answer. The rest of these are columns, so that's false, and this is just a false representation. So the only answer is I. Okay, so question N. Given two non-zero vectors u and v, if the magnitude of the cross product u and v equals 0, okay, so this means that we need to use some right-hand rule. So this is the cross product u and v, and equals 0 usually refers that it's perpendicular. Which of the following must be true? Well, u equals negative v, not necessarily. False. U equals 1 over v, not necessarily. Parallel? No, definitely not. If it's parallel, means it would not be multiplied to equal 0. This gives a perfect 90 degrees. This would mean there's some sort of similar proportionality involved. Okay, it's either perpendicular or it has the same magnitude, but just like a bigger version of it. That's parallel lines, at least. Is it perpendicular? Yes. Because the way it works, you've got to imagine this UV vector and imagine a vector across this direction. Could be either the A, or we could use the right hand rule, and this could be the B. So it doesn't matter what this actual angle is, but the bottom line is, in a 3D spacing, this would be a perpendicular line. So this is kind of in the shape of a parallelogram, actually. But yeah, and we'll get to this in theory after. For the sake of this question, we go consider the right hand rule. And that's really all you need to know. Okay, so the cross product is always perpendicular when it equals 0. Very important. Okay, let's have a go. Next one. Okay, so in this one, I'm going to walk you guys through how to find the inverse of a 3x3 matrix using a very simple example, a very linear based one. Because the whole purpose is to really get down the formulas and know the steps inside out. Okay, so what do we need to do? So I need you guys to write a list of steps, okay? And this is where we're going to go. So the first step is to firstly find the determinant of m, which is, thank God, very easy in this example. We're going to use this is going to be one of the final steps. The second step is to find the transpose. So we're going to call this m to the power t. The third step is going to be called the agitate matrix. So this is denoted as A agitate and then m. ADJM. And this is linked to something known as the matrix of cofactors, and on the final step would be the actual inverse, and this is going to be a combination of the very first step and times the agitate matrix, and this will give us one of these three hopeful matrix. So let's have a go. So let's work out firstly the determinant. Okay, so this is, if you don't know how to do any of the steps, I've got videos on each of these, and hopefully you can have a look. So I'm going to do the first one, the determinant down here. So the determinant, how do we calculate it? Well, you can think of it as this. So the way I do this is I would rewrite this 3x3 matrix with 2 additional columns. So let's write here, yeah. So I'll make a little arrow there. So it'll be 2 0 0 and then 2 0 2 3 0 0 0 1, and then copy the first 2 columns. So 2 0 0 0 3 0. Now all you need to do is literally find the determinant by multiplying the diagonals. So what I'm going to do is firstly highlight this. So firstly, do all the possible diagonals you can from one corner to the other, and all of these in the circle will be the ones you're going to multiply inside, and then you're going to sum them up. For example, 2 times 3 times 1 will give us the value of 6. All these zeros multiplied to give us 0, and of course these ones are also 0. Next, we're going to subtract the other corner, so the other diagonal. So I'm going to change the color to, say, green. And guys, make sure you do the same thing. So make sure you correctly identify the diagonals, yeah? And the last one is these 3. So you can see all of these have 0, so for sure they're all going to be solutions of zeros. That means the final solution is going to be, thankfully, 6. So we know the first step, the determinant, is 6. Now, what is the next step here? To find the transpose. Well, the transpose is dead easy, guys. The idea is to literally flip the rows and it becomes a column. So let's call this empty. So we have the matrix. This row now becomes 2 0 0. The next value, I'm going to change the color of the pen. So do this as a highlighter. So 0 3 0 goes downwards, 0 3 0. And the final one, 0 0 1, well, you got it. but I'll just do it anyway, would be 0, 0, 1. All right, cool. That's easy. Now, the agitate matrix. So this one is the very lengthy process where we have to find so many determinants. And this one deserves its own video. So the key idea is that we need to replace each of these 9 figures with the determinants of those that are not in its horizontal and vertical line. For example, if we want to replace this 2, we need to find the determinant of these 4 figures because it's not in the horizontal vertical line. So there's a lot of 2 by 2 determinants. So let's have a go, yeah? Let's think of it like this. So let's call this let's just call this for now M prime, yeah? Type of M. What's it going to be before we get to the agitate? So replacing 2, we need to find the determinant of 3 of this little 2 by 2 matrix, which consists of 3, 0, 1, 0. So the idea is to multiply diagonals of 3 times 1 minus this one. This will just give us a 3. Next one here, we need to look at these 2 figures, 2 zeros and 2 ones. Because you've got zeros in each corner, the determinant will be 0. Now you look at this value, and now you got this 2 by 2 matrix. So you got 0 times 0 minus 3 times 0, which is 0. Again, over here, so now we look at this value. So now we're going to look at these 2 zeros and 0, 1. So this will give you a 0. So basically, you're going to end up with a bunch of zeros. I can already see where the zeros are coming. Now for this middle figure, we need to use 2, 0, 2, the first 2 is the last 0, this 0 and this 1. So 2 times 1 is 2, minus 0 is 2. And this one here, this corner, what's it going to be? It's going to be, we're going to need to replace the 1. So the 1's going to be these 2 figures, these 4 figures are 2, 3, 0, 0. So 2 times 3 is 6, minus 0 is 6. Now, what do we do here? So now we need to find the agitate. So, okay, now we need to find the agitate matrix. So now we got this M prime, thank God. So all we do now is multiply M prime with something known as the matrix of cofactors. So it looks a bit like this. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So this is known as the diamond of negatives. And all you have to do literally is replace. We don't literally multiply. You just replace. You just invert every sign here according to this technique. So when you got positive, you keep the signs of its position. If you got negative, you flip the signs. For example, you got 4 negatives here in the diamond position, meaning these 4 figures will have to flip to negatives. Or no, they'll just flip signs. So if they're already negative, it'll be positive. Because those zeros, well, 0 times a negative will still be 0. So actually, the agitate is actually itself. So the agitate matrix in the end will end up being the same thing. So 3, 0, 0, 0, 2, 0, 0, 0, 6. Again, guys, this is just an easy walkthrough, so you guys don't get it doesn't get too complicated with all the hard numbers. I just wanted a quick, simple video for you guys. Now, finally, the final step is to do the my God, the inverse of M, and that all is simply multiplying your agitate with the 1 over the determinant of M, which is the very first step we took in the beginning. And thank God that's easy. So all we do now, so we can say finally that the M inverse is going to be 1 over the determinant, which was 6 times matrix of cofactors, or agitate matrix, sorry. And then multiply everything by a 6. Everything, all the zeros stay the same, but the 3, 2, and 6 become 3 over 6, which is half, third, and 1, and zeros all around. And that's it, guys. And this should be part 2. Okay, here we go, part P. So, which of the following is the inverse of W? Oh God. Just when you think you've done one inverse, they bring back another one. You know what, I'll be honest. My advice is to repeat the steps because this takes a long time to solve, as you just witnessed. And anyway, when you do this, I can already see the answer, that the answer is actually going to be part 2. Okay, so I actually did this separately to double check. But if you follow the steps carefully, you will conclude that the answer will definitely be this one. Okay, well, let's move on. So Q, the following matrix represents which of the following transformations? Okay, so all I want to say is that when it comes to transformations, we are only concerned about certain values. We're concerned firstly about this part here, and then we're concerned about this part here. The one has to be fixed. Now these figures here, let's just look at this one here. Okay. These are either meant to represent stretching, i.e. scaling, or rotation. Okay, and the way it works for scaling, usually we use a scale factor k, where if k is 1, then it's an identity matrix, meaning there's been no scale, it's the same. If it's bigger than 1, means it's actually stretching. If k is less than 1, then it's compressing. So in other words, it's becoming smaller. So it makes sense. If the scale factor is less than 1, it's smaller. Bigger 1 is stretching. It's increasing. Could be doubling if it's 2, for example. However, if it's negative 1, it looks more like a reflection, doesn't it? But be very careful, because the general formula, according to here, I'm referring to Wikipedia, is that stretching occurs. This is a 2 by 2 matrix, but we consider the same effects for a 3 by 3. Is that this figure here, this k, could be considered the same thing as a matrix in this format: 0, 0, 1, and then t, y, tx. Okay, so a rotation, however, has the same property. So those 4 I highlight are actually in this format. If you look closely, you got cos theta minus sine theta, and here we got sine theta cos theta. If we were to reproduce this on the question paper here, we can see that these two -1 are equal to cos theta. So we're actually in the middle of rotation. So the answer would be rotation. And just to prove it, let's let all of these figures equal the figure it represents. So cos theta clearly equals -1. If you were to cos inverse this, you will get 180 degrees or pi radians, depending what you're using. If you were to cos inverse, now let's take a minus sign. Yes, suppose you have sine theta equals 0. Well, sine inverse would actually give you 0 still. Same thing for minus sine theta. This would also give you theta equals 0 for the same expression. So actually, bottom line is the solution is going to be a rotation, and that's all it is. The figures on the right would represent a translation. Okay, so this would be translation in the x, translation in the y. So this would be a movement. Translation is a movement across a vector. Anyway, this is the right answer, it's rotation, okay? Now, let's move on to R. So given complex numbers z1 and z2, find the sum of them to z1 plus z2. Easy, so you just add up the numbers. So 1 plus 5 is 6, minus 2 plus I is minus I. So this is very easy, very straightforward. Given the complex number minus 3 plus 2i, find the complex conjugate. So complex conjugate means the other version. So usually, think of it as a quadratic equation. When you solve a quadratic, you're left with something like x equals a plus minus b. For a complex number, you're left with a plus minus bi. So the conjugate would be, the plus minus b would be the I part. So it's going to be minus 3 minus 2i. So the conjugate means the other one missing. So we got plus, we want a negative. Lastly, so given the complex number z equals 3 times cos pi plus I sine pi, find z cubed. Okay, so this is a typical complex expression where this number 3 represents the radius and pi here represents the angle. So technically it's a bit like this. So r equals the radius of 3 with an angle of pi. So 90 degrees in other words. Okay, so what do we do? How do we find z cubed? Well, thankfully there's a formula given by de Moraes himself, and it's called de Moraes Theorem. Okay, so not many people know about this actually. It's kind of weird. Most engineers in the world have no idea who the heck this guy is. But who is he exactly, and what does he do? And what is his main key formula that's useful here? He stated that for any power of n, we can say that the radius itself can be powered by n, and the cos term, which is actually similar to a Euler function, where it's e to the power of I theta, can also be powered by n. It makes sense because if you power this by n, everything is powered by n. And this is equivalent to r to power n, and this entire term is the same as these terms. So it would be cos n theta plus I sine n theta. Now what do we have exactly? So we know we have that pi is theta and r is 3. So this means that the solution is going to be firstly 3, which is r to the power 3. So 3 to the power 3, which is actually 27. So we can write 27 cos n pi, so n is 3, instead of theta, we can say pi plus I sine 3 pi. And that's it. That's literally all they want you to do. And where is that? So no, it's not square, it's not cubed. And you don't multiply by 3, it's definitely not all the above. It's actually the second solution. And that's it, guys. I believe that's the end of the paper, and this will lead to part B. So I hope you enjoyed this. You know, if you really did, give me a like, share this with your classmates and to other students in your course. You know, let everybody know, and recommend me as well if you can. But other than that, I shall see you next time. Ciao.